Hi, welcome to lesson 6 of solving simultaneous equations. Today we are looking at the final stage of elimination. Before we begin today's lesson though, can you pause the video and have a go at these two starter questions? These are just examples from the previous day's lesson. Okay, let's have a look at the solutions for these questions. So in A, we need to decide which variable x or y to eliminate. We need the same amount of x or the same amount of y and opposite signs. We have the opposite signs in the y terms, so we're going to multiply both equations to eliminate the y terms. Remember, we multiply by the coefficient in the opposite equation. So for equation 1, we will multiply by 2, and equation 2, we will multiply by 3. So equation 1 becomes 4x minus 6y equals 14. And equation 2 becomes 21x plus 6y equals 36. Remember, every single term in the equation needs to be multiplied. Now we are able to eliminate the y terms. We do this by adding the two equations together. This will give us 25x equals 50. We divide to find x equals 2. Now we need to find the value of the y term. So we sub x equals 2 into one of the original equations. I'm choosing equation 2. So the equation 2 becomes 14 plus 2y equals 12. Take the 14 over and 2y equals negative 2. Therefore y equals negative 1 when we divide. So our solution here, our point of intersection, if we were drawing it on a graph, would be the coordinate point 2, negative 1. If we look at example B, the same idea again. The first thing we have to do is decide which variable we are going to eliminate. We need the same amount of x or the same amount of y in each equation and opposite signs. Again, in this example, we have opposite signs in the y term, so we need to multiply both equations here to eliminate the y term. So equation 1 will be multiplied by 3 and equation 2 will be multiplied by 4. Remember, we get these values from the other equation. Equation 1 becomes 9x plus 12y equals 60. Equation 2 becomes 16x minus 12y equals 40. Now we can eliminate the y terms by adding the two equations together. That will give us 25x equals 100, and when we divide we get x equals 4. Subbing x equals 4 into one of the original equations. Equation 2 becomes 12 plus 4y equals 20. So take the 12 over and subtract, so 4y will become 8, so y is equal to 2 when we divide. So our solution here is x equals 4 and y equals 2, so the point of intersection, if we were drawing it on a graph, would be the coordinate point 4, 2. For today's lesson, the learning intentions and success criteria are exactly the same. For the last stage, back to basics, we still need to remember for elimination that we need the same coefficients and opposite signs. But the question is, what do we do if we have neither of them? So we still multiply both equations, but this time one of the values needs to be negative so that we get the opposite signs. So let's look at an example. So here we want to find the solution to the pair of equations 2x plus y equals 1 and 5x plus 2y equals minus 3. Notice we don't have the same amount of x, we don't have the same amount of y, and we don't have opposite signs. So we need to multiply both equations just like before, but this time one of the values needs to be negative so that we get the opposite sign. So we need to decide whether to eliminate the x or the y terms. To eliminate the x terms, we would need to multiply by 2 or 5. To eliminate the y terms, we would need to multiply by 3 or 2. That's slightly easier, so I'm going to go with eliminating the y terms. But this time, remember, one of the terms needs to be negative, so multiply equation 1 by negative 2, multiply equation 2 by 3. it doesn't really matter which value is negative. The solution will work out to be exactly the same. So let's carry on. Equation 1 will become negative 4x subtract 6y equals negative 2. Remember your rules for multiplying by negatives. Equation 2 will become 5 threes is 15x plus 2 threes is 6y equals 3 times minus 3, which is negative 9. When we've got to this stage, we can see that we have the same amount of y in each equation and opposite signs, so now we can proceed with our elimination. So let's have a look at example 7 in full. Okay, so we've said we decide which variable to eliminate. So we just do that by just looking at what we would need to multiply by for x and what we would need to multiply by for y, and just choose the one which is easiest. Then we multiply both equations, but remember, one value must be negative. And then once we've done that, we follow the same method as we've done throughout the elimination process. So let's have a go. So choose to eliminate the y terms. So equation 1 gets multiplied by negative 2 and equation 2 gets multiplied by 3. So as we said previously, this becomes minus 4x subtract 6y equals negative 2 and 15x plus 6y equals negative 9. To eliminate, we add the two equations together. This will get rid of the y terms and we will be left with 11x equal to negative 11, so x equals negative 1 when we divide. Substitute x equals negative 1 into one of the original equations. Again, just choose whichever one looks easiest to you. So equation 1 will become, in this case, minus 2 plus 3y equals 1. We take the minus 2 over and add, so 3y will be equal to 3. So when we divide, y equals 1. And our solution therefore would be negative 1, 1. Okay, let's try a second example just to make sure that you're following the process. So here we're asked to solve the pair of equations 7x subtract 5y equals negative 1 and 4x minus 3y equals 0. So we need to decide which variable to eliminate, multiply both equations. One value must be negative that we multiply by, and then follow the same method as before. So let's decide if we want to eliminate the x terms, we need to multiply by 7 and 4. If we want to multiply the y terms, we need to multiply by 5 and 3. That's slightly easier, so I'm going to decide to eliminate the y terms. To do that, we need to multiply equation 1 by 3. And equation 2 we will multiply by negative 5. Remember, one of the multipliers needs to be negative. Equation 1 therefore becomes 21x take away 15y equals negative 3, and equation 2 will become negative 20x plus 15y. Remember, you've got minus 5 times negative 3, so that will give us plus 15y, and that's equal to 0. So now we can eliminate the y terms by adding the two equations together. So we end up with 1x is equal to negative 3. Now we need to find the y value. So substituting x equals negative 3 into one of the original equations, I've chosen equation 2. So it becomes minus 12, add 3y equals 0. Take the minus 12 over, and 3y becomes 12. Divide to get the y term, so y therefore equals 4, and our solution will be minus 3, 4. Okay, now it's over to you. So if you go to poster files on the team to get today's exercises, and make sure you answer your questions in your class jotter showing all your work in, and then mark and correct your work at the end, please. If you have any issues, just post or email. and I'll get back to you. Thank you.